Hello again. Today we are talking about arrays, right? Today we're talking about arrays. What is an array? Array, we could define an array here as a collection of elements. Okay. What is an array? An array is a collection of elements. Creating an empty array, we could say var um, people names is some array of strings, just like that, right? Using our initializer syntax as well. So here we have creating an empty array, var people names, because we want to mutate people names, and the type is string. So this will contain a collection of strings. So here we defined an array as a collection of elements. Elements could be of any type. Elements could be elements of string, could be elements of ints, could be elements of bools, could be elements of your own custom object. It could also be mixed, but be careful here. This becomes a bit harder to work with. So you could have heterogeneous types, meaning a mixed array of different types. Heterogeneous here. So you could have basically mixed types in an array, but avoid this at all costs because Swift is a safe language. It will be harder to go ahead and parse some array with mixed types. So be very careful here. Try to define your array such that our people names only has strings in it. If you want to have people phone numbers, for example, this could be an array of people phone numbers. Here, I could define this as an array of integers, just like that, right? Okay, cool. So here, really try to avoid having an array of mixed types. Here we have an array of strings, and here we have an array of integers. So it will only work with integers. Okay, so going on, creating an array with a default value. What does that look like? Here we could just create some empty array. Let's just say new array. So new array here, and we could use the syntax that says array. So you type in array, open parens, repeating. I want to repeat some number, for example, 0. I want to repeat 0 for 5 times. What does that look like? If I print new array and I run it, here I get a new array with 5 zeros, right? There's times where you could want a use case like that, but this particular initializer here gives us access to this. So I could create a new array. I repeat 0 5 times. Okay. Creating an array by adding two arrays together. Okay, so let us create two arrays. We'll say let numbers 1 equal to, we'll say 1, 2, 3, and we'll say let numbers 2 equal to 5, 9, and 90. And we want to add those two together. So let's go ahead and do so. So here we'll say let combined arrays equal to numbers 1. The same we could add two numbers together, we could add two arrays together. Okay, so here I could basically say numbers 1 plus numbers 2. And if I print combined arrays, just like that, I'll get 1, 2, 3, 5, 9, 90. It took 1 to 3, and it added 5990 to it. And now we have a combined array. What's an array literal? Well, we've created array literals. So here, this is an array literal, where you're literally just creating an array. Here, I could just create an array of Boolean values, true, false, true, false, true, or just false, like that. So this is literally an array where you just use open bracket, the type, close bracket. And here I could say another literal. And here I could say Bob, Allison, and Rachel. Okay, so those two are array literals. This is also an array literal, open square bracket, the types. Okay, I guess I could just show us what a mixed array or heterogeneous array could look like. So here I'll say mixed array, and I will start putting in types. I'll put in a Boolean value. I'll put in an integer. I will put in some string, like that. And at this point, the compiler will start to complain. Here the compiler says, heterogeneous collection literal could only be inferred to be of type any. So add explicit type annotation. Remember back in our earlier lessons, we spoke about type annotation. So here we need to explicitly type annotate this heterogeneous array by saying it's any type, because here it's any type. It could be a Boolean value, it could be an integer, it could be a string. Okay, so this gets harder to work with because now, as we see later, when we go through a for loop, we have to check what type it is for each of those elements. So be very careful when working in Swift, especially. Just make sure we are strongly typing our arrays quickly. So here, this is a string, this is an int. This starts off as being int. So at any point, we cannot change it from int to string. Okay, so accessing elements. Let us see this. So here we have count. If I want to count how many objects I have, say in the mixed array, I could say print mixed array.count, just like that, and run my playgrounds. And here I'll get 3, right? I have 3 elements in my array. So 3 elements in array. Okay. Next, we could check for empty, right? Does the array contain elements in it? So here we have an is empty. Currently, we have our people phone numbers. Let's see if it's empty because we created it here. And at this point, it's empty. So is people names. Both do not have any values in them. So we could use the is empty variable here. I could say if people names dot is empty, go ahead and print people names array is empty, just like that. Okay, and now if I run it, and here it will say people names array is empty because here people names does not have any elements in there. Okay, let's go on to talk about subscript syntax, right? What does that look like? So here, if I want to access, let's go ahead and create some sort of array. We'll say numbers. I don't think we have numbers yet. Or rather, we'll just say languages here. So languages is, I will say, let's go ahead and do Swift. We'll do Swift, and we will do Java. We'll do Java. Next, we will do Perl. We'll do C, just like that. And if I want to access, let's just go ahead and make this a var so we could add numbers to it or add more elements to it. So here we have languages. And if I want to access languages, for example, the way we access elements in an array is using subscript syntax. What does subscript syntax look like? A subscript syntax is basically an open square bracket and a closed square bracket. And in between the open and the square bracket, you put in the index you want to access. If you want to access the first element, it's index 0. So in arrays, we start counting array elements from index 0. So here, if I want to access the first element, I would say index 0. So let's just say print the first language in languages is, use string interpolation here and say languages at index, so open square bracket, the index you're interested in, and close square bracket. So this is called subscripting. This is subscript syntax. So if we run the code, here it will say the first language in languages is Swift. And here we have Swift as the first element. If I want to access Perl, I would put in 0, 1, 2. So this would be the second index, right? So this is the first index. Again, we count from 0. Second index is 1. Third index is 2. Okay? So if I go ahead and I run this, here we will see languages Perl at index 2. Okay? We also have access to first, last, random element. So first will return us an optional. So first here is an optional on an array. So for example, if I say, let's do let first equal to, let's use a different array. Let's go ahead and access another literal. So another literal dot first, right? Another literal dot first, here we see first returns a string optional because again, Swift infers the type. So here we have string optional. So if I go ahead and type in first and I print first and I run it, it tells me it's an optional. It's an optional because there could be a value or maybe there's no values. Maybe the array is empty. So this is a safer way to access the first element in an array as opposed to saying, for example, if we were to do this and we were to print another literal, it's going to be Bob. But if we were to go ahead and take people names, for example, people names, and we run it, we'll get a crash because people names is empty and we're trying to index into people names. So be very careful when using indexing to access an array. You want to make sure the array has values in it. So a safer way would be either using optional, like let me actually redo this. So we could say if let first, where we unwrapping the optional, say people names like this. And here I could say print first is first, like that. So this is safer. If you want to say people names like this, you probably have to do something like say if people names dot is not empty, then we could go ahead and access it this way, like that. Okay. So here we have people names. This is dot first. Okay. So first is an optional. So optionals, as we saw, we need to unwrap optionals as we saw earlier in this basics lessons. So here I'm unwrapping the first optional value. So if this has a value, it will get assigned to our first constant here, which we created, and we'll go ahead and print the constant. If it doesn't exist, nothing happens. This is safe. My app won't crash. Very similar, I'm checking here if people names is not, remember our unary operator, not. What does this do? If it's true, or rather, if it's true, rather, if this is true, it will say not here. So if this is false, we want to say if people names is not empty, meaning if this is true, right? So if this statement is true, meaning it's not empty. So the opposite of not empty is false. So if this false value is true, okay? So if this is true, come in here and go ahead and print people names. Else, let's put a statement here because we know it's empty for sure. We'll just say people names is empty. Okay, and let's go ahead and run this. Okay. People names first, people names, line 444. People names, this should be safe. Stop this and run it again. Playgrounds is being a bit slow today. People names at first. This should work safely. Playgrounds does act up sometimes. Sorry about that. We might have to relaunch Playgrounds. Okay, let me actually stop my Xcode and run it again. Okay. Run that again. Okay. Again, sometimes Playgrounds does have hiccups here. Sorry about that. But here we have first is an optional. We try to unwrap our first value. It doesn't exist. In other words, it's empty. So first is not getting printed. And then this is safe. This is a safe way to do it, safer way to do it. Next, we come here, we check to see if people names is not empty. In other words, not empty is true. And here we come in, it's empty. So our app doesn't crash by accessing index 0. And now we're able to say people names is empty, okay? This would be the preferred way to do it. Line 42, where you're unwrapping the first value. But if you're in a situation where you want to index using subscripting, make sure the array is not empty, okay? Or the count is greater than 0, okay? Last is very similar to first, so we won't exactly show what that looks like because they're very similar. We'll go on to random element. So if I create, say, numbers, we have numbers already earlier. We have another literal. Okay. So another literal, let's get a random value from it. Or let's create a literal array with some values. Let's say 4, 1, 2, 9, 0. And we want to get a random value. So here, if I print random value, well, I haven't gotten a random element. Random element, I'll get 4. Again, it's an optional. If I run it again, I'll get a different value. I got 1 this time, okay? So random element is a function that returns you a random value from an array. Here we're just using an array literal, but it could easily be the name of your array. And again, it returns an optional because maybe the array is empty. So it returns returns an optional value. Great. Subscripting to change a range. What does that look like? Here, if we have contacts and we have an array of contacts, we love using Bob. Let's go ahead and use Alex. Let's go ahead and use Sally. Let's go ahead and use Tom, for example. Okay, use subscripting to change a range. What does that look like? Here, I could say this actually needs to be a var because we want to change it. So here I could say contacts at range, let's say 1 through 3. We want to change those contacts. We want to say William. Let's make it William and Quincy. Let's see what we have. So if we say print contacts and run this, now we have Bob, William. So we have Bob, William, and Quincy. Because what happened is we went from this index through Tom. Here, this is a closed range. Back in our earlier lesson, we spoke about ranges. So we basically changed those values from index 1 through index 3. We went ahead and we changed it to William and Quincy. Okay, so if you ever want to change a range of values within an array, you could use that syntax right here and just basically overwrite the values at that index. Okay. Comparing arrays, let's go ahead and do so. We'll actually just compare arrays literally here. So 1, 2, 3. Is 1, 2, 3 equal to 1, 2, 3? Actually, let's just do 2, 3 like that and run it. So here it's false, right? Because 1, 2, 3 is not equal to 2, 3. On the other hand, if we have 1, 2, 3, we could compare it directly with another array, 1, 2, 3, and run it again. And this time we get true because 1, 2, 3 equals to 1, 2, 3. Okay, so double equal sign, same as we have with numbers, strings, and so on, we could compare them directly. Because what happens is this array conforms to comparable, equatable rather. We'll talk about protocols later in the course, but right now we're able to compare those two arrays together. Not equal is the same thing. So if I was to go ahead and copy this string, if I was to copy this array right here and run this, not equal actually. So if I say 1, 2, 3 is not equal to 2, 3, I should get back true because they're not equal. And I get back true here. Great. Adding elements together, we did that before. So if we were to take those two arrays here and add them together, say combine, and I say 1, 2, 3, plus I'll get combine and print combine. Okay, so here we have combine 1, 2, 3, 1, 2, 3. Okay, it just added them together. It doesn't care about duplicates. Okay, we'll come into sets and we'll come into all that later, but for now we're just able to add two arrays together. You could also use append if I want to add. So say we have contacts here currently. If I was to just go ahead and print contacts right now, let's see what we have. So our contacts is Bob, William, and Quincy. Okay. If I want to add a new contact, I could say append new element. It expects a string. So here I could say an, just like this, and I could print contacts again. And this time I will get 4 elements because now and also got added. And when you append to the back, right? Or rather to the end of the array. So our array before was Bob, William, and Quincy. Now our array has a new element that got added to the end. You could also append contents of. What does that look like? So here, if we have contacts, I could say append. So there's append one element, and there's append a sequence. So here I could add a sequence, which is similar to the types in our array. So here I could add in, for example, multiple values. I could say Zion. I could say, let's see, Eric, that. And now if I was to print contacts, my contacts now will get more values added to it as a sequence. So here, if you want to add a sequence of multiple elements, you could use contents of on the append function. Let's go talk about insert. So contacts dot insert. So I could insert contents. Again, I could insert a sequence into my array, or I could insert one element into my array. Here, I want to insert Rachel at some index. Let's just say, since we have, let's insert into index 1. And let's see what we have. Let's print contacts. Run this again. At this point, is Playgrounds going to be with us? Oh, it's done. Okay, so here we have Rachel got inserted at index 1. What happened to William? William got shifted because what we did was literally take Rachel and insert Rachel at index 1. So William got shifted 1 index forward. So now William is at index 2 and Rachel is at index 1, because that's what we said. We said insert Rachel at index 1. So whatever is at index 1 gets moved over and Rachel gets replaced there. We've done add in before, and add equal is very similar. So we'll go over those and remove add. Let's go to removing elements. So here we have our contacts, and contacts has to be a var. It cannot be a constant here, so it has to be a var. So I could say contacts remove. Let's remove at some index. So let's see, we want to remove, okay. Let's say we want to remove Eric. Eric is at the last index. How can we get access to Eric? Well, a good way to get access to Eric is say contacts dot count, which will be 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 elements in here. If we say contacts count, let's see what happens. Our app will crash, right? It will crash. Index out of range is the error. Why does it crash? Because there's no index 7. If we count again, we count from 0. 0, 1, 2, 3, 4, 5, 6. 6 indices. The count is 7. The indices is 6. So what do we have to do? Remember, we count from 0. The count is 7, but we count indexes from 0. So here we have to remove, we have to minus 1. Why do we have to minus 1? Because if the count is 7, the last index is minus 1. So the last index is 6. So anytime you want to access the last index of some array, get the count and minus 1, because we start from counting at 0. And now if we print our contacts again, Eric should be gone. Our app should not crash. Okay, so here Eric is gone. And now we have 6 elements, right? Cool. You could also use remove last as opposed to doing what we did earlier. So here we could say contacts dot remove remove last, just like that. So for purposes of just removing a different index, let's actually just say remove index at, let's move William. So 0, 1, 2, remove William here, and remove last will remove whatever the last element is. So let's go ahead and run it. Okay, let's actually print as well. So print contacts, run the app again. So, okay, so we remove William. Eric was the last one. We also remove Eric, okay? We removed William and we remove Eric by saying remove last. We remove William. William was at index 2. And we remove last. Eric was at last, at the last element, okay? And there's also remove first. We won't go through remove first. There's also pop last. Pop last does very similar to remove last, but pop last is safer because it returns an optional. And let's see what that looks like. So if I have, let's create a new array. Let's say cities, like that. And let's say we have Stockholm. Let's say we have New York. Actually, let's make it empty first, and we'll add to it. So let's make it a string array. We'll make it a string array, and let's go ahead and use remove last on it. So if we say cities.remove last, what happens? Let's try to remove the last element. We'll get a crash because there's no elements. Empty. Array is empty. So remove last will crash if the array is empty. On the other hand, if we use pop last, so cities.pop last, and run the app again, our app won't crash because pop last tries to remove an element. If there's no element, it returns nil. So if no element returns nil, does not crash the app. Okay. So if you want to remove the last element and you're not sure if the element has values, use pop last here, and it's safer. It's an optional, but it is safer as opposed to using remove last directly. There's also remove all, which removes all the elements. So in our cities, for example, if we do populate our cities array, New York, Stockholm, like that. At this point, we have elements here. So if we print cities, right, we have New York and we have Stockholm. If we want to remove everything, empty the array, on the other hand, we have no empty, right? We have remove all. So remove all is going to empty out our array. So if I say print cities now, it's empty, okay? Okay, so let's talk about drop first now. What does drop first do? Let's just go ahead and copy. Let's recreate. Let's get our cities happening again. So cities. Okay, what does drop first do? Let's actually create, we'll call this cities splice. And here we'll say cities.drop first. And drop first, let's take a look at drop first here. So drop first says returns a subsequence, right? Containing all, but the given number of initial elements. So what does that mean? So here we said city splice because it's a splice of cities, or I could say cities subsequence. And say drop first, and drop first here takes a integer. If you don't provide an integer, let's see what happens. So if I say print cities subsequence here, Now subsequence is an array subsequence type. Just go ahead and say city subsequence and print. And here it says Stockholm, right? We had New York and Stockholm initially, and now we have Stockholm because it dropped the first element, which is New York. We could specify 1 as an integer. It will be the same outcome. So the default is just dropping the first element. We could also specify the first 2 elements. And let's see what happens to New York and Stockholm. So New York and Stockholm is now gone. It's empty. If you provide more elements than we have, let's see what happens. For example, I say drop the first 5 elements. Right? Again, there's only 2 elements, so it will drop both 2 elements, but there's no other elements. If we had 5 elements, it would also drop the 5 elements, and so on and so forth. Okay? Let us bring back our cities again for drop last. And let's see what drop last looks like. So here I will say cities sub 2. And I'll say cities dot drop last. Let's just drop the last. In that case, Stockholm. Actually, let's create some other cities here. Let's do Boston. And let's do Los Angeles. All right, let's say drop the last 2. So let's say drop last 2 and print cities sub 2. And here we get New York and Stockholm because it dropped the last 2 elements. Okay, so anytime you catch yourself wanting to do something such like this, you could go to drop first and drop last. Okay, iterating over an array. All right, let's get to cities. Let's bring back our cities here. And iterating, as we saw earlier, means to loop over or to go through each element. So here, what does iterating mean? I want to go through and visit New York, visit Stockholm, visit Boston, and visit Los Angeles. How can we do that? The easiest way to do this is using a for loop. Let's do it right here, accessing only the item. So here I want to say for item in cities. Let's go through the code. Item is a constant. I could name it anything. I could say city, which is easier to read because now somebody's reading your code. They understand that you're going through each city or cities. So city here is singular. Cities is plural. So I'm saying for city in cities, right? As long as this is true, right? So for city in cities, as long as this is true, there is a city here, there is a city here, there is a city here, there is a city here. At that point, we are done. There's no more cities. So we should get 4 cities getting printed out. So let's go ahead and print city and run our code. So here we see we printed New York, we printed Stockholm, we printed Boston, and we printed Los Angeles. So this is the syntax for some element in a collection. For some element in a collection. Okay, that collection could be anything. It could be an array. Well, it has to be a collection. It has to be a collection of elements. So a string is a collection of characters. An array is an array of elements. We'll come to dictionaries in the next lesson. Okay, so let's move on to accessing the index as well. So if, for example, we go through city in cities, just like that, and we print city. Okay, if the question was, please tell me at what index is Boston, okay? So here we say if city is a string, how do we compare strings? Double equal sign. So is city equal to Boston? I want to print city. I run my code. I get back, well, let's actually use some string interpolation here. City is Boston. Let's also use some escape characters. So we'll say, I want to escape the first backslash here. I want to say Boston, and I want to escape this one as well. So we'll say city is Boston. Let's run the code again. And here I have city is Boston. Great. But my interviewer told me to also print what index it is, right? What's the index? Here we see it's 0, 1, 2, 3. How do I get access to the index? Okay, that's the question here. How do I get access to the index? So how do I get access to the index for Boston? Okay. The best way to get access to an index when you use a for loop, right? On the collection, there's a function you could use called enumerated. Enumerated returns a sequence of pairs that includes the index, where n represents the consecutive integer starting at 0. We count arrays from 0. And x represents an element of the sequence. Great, so this is what we need. So enumerated gets us back an index plus the element we're looking at, which is city. So at this point, we have the index and we have the city. We use the city here, but the question also asks us what index is Boston. So here we could say city is Boston found at index. And here we could say index just like that. And now if we were to run the code again, we'll see city is Boston found at index 2, 0, 1, 2. Okay, so anytime you catch yourself in a for loop where you are trying to access the index, please remember enumerated is going to get you access to this index. Okay, let's go on to finding elements. Finding elements. So here we have finding elements. Here we have, let's actually go ahead and create, actually we have cities already. So here I could say use a for loop, or rather we could just use our cities that contains, let's look for Stockholm, for example. And this returns a Boolean value. So if city contains Stockholm, let's print looks like we are in Sweden, just like that. Okay, so contains is a way to find elements. What does contains do? It returns a Boolean value. If we were to option click here, we'll see contains returns. So here we have our arrow. We'll talk about functions. We haven't spoken about functions yet. But here we have contains returns a Boolean value. So here I say, if city contains Stockholm, return true or false. If this is true, go ahead and print looks like we are in Sweden. So if we run our code, it does get printed. It looks like we're in Sweden because Stockholm indeed is in our array of cities. But if I was to put in a different city here, for example, if I put in Miami, this is going to be a different, this would be a different Sunshine State. Let's just say Sunshine State here. Else, let's just print city is not in array, for example. And if we were to run the code again, here we'll see city is not in the array because city does not contain Miami. Cities does not contain Miami. But if we put in Miami here, right? If we put in Miami and we run the code again, now we'll see we're in the Sunshine State. okay? Because it got printed where we got true. Other ways to find elements, we have first index. So here it returns an index. So if I was to find Los Angeles, we'll say if let index, because it's an optional. As you write in Swift, you'll come used to knowing if something is an optional, you need to unwrap it. So writing syntax like that will become second nature to you because you know at some point first index returns an optional. So that comes with practice here. So here I have cities. I'm looking for the first index of some string. In that case, I'm looking for the first index of Los Angeles. If it does exist, it will return us the index. If it doesn't exist, we'll put an else statement. We'll say print city does not exist in cities array. If it does exist, we'll just print found city at index, and we'll use string interpolation to put in the index. And let's run the code again. So here we'll see found city at index 3. If we go back to our cities, 0, 0, 1, 2, 3. So we found Los Angeles at index 3. Okay. Same thing for the last index. If you want to find the last index of some string, you would have to do the same code similar to first index. Let's go to min and max. So if we have, let's just say other numbers or ages rather, let's just put ages. Ages is just an array of ages. Well, somebody could be 0. If they're 6 months old or something like that, we'll just say 0. 56, but we cannot have negative. There's no negative ages. And let's go ahead and use, let's say, let min age equal to ages dot min. Returns the minimum element in the sequence. So this is what min does. And if we print min age like that and run it, indeed we get 0, because 0 here is the minimum value in the array. Again, it's an optional because maybe ages array is empty. If it's empty, it will just return nil. If it's empty, just like that, it will return nil. Okay, this is why it's optional. Optionals are really good for situations like this. Very similar to max. Let's just say max age, and we'll say ages dot max. Okay, we'll use string interpolation here for now. If we do not have a max value, we'll just return 0. Okay, nil coalescent is a double question mark. Nil coalescent is a way to give your value a default value. So here, if we do not find a maximum value, the default will be 0. Right? So here we're using nil coalescent to unwrap an optional. And let's go ahead and print max age. You see now it's not an optional. There's no yellow warning as opposed to line 173. Because 173, we did not unwrap it. We could easily unwrap it by providing it a default value of 0. And at that point, our warning will be gone because we are unwrapping it using nil coalescent. So let's go ahead and print max age. Max age is 89, right? 89 is the maximum value. Okay, let's go to prefix and suffix and see what that looks like. Very similar to drop first and drop last, but the difference is they're not removing the elements. They're just returning the elements. So if we were to say ages, let's use ages on 171. And let's say prefix ages. Ages dot prefix takes an integer. So what we want to say is return us the first 3 elements, for example. Return me the first 3 elements. It's not going to remove them, just return me. So if I print prefix ages, I get back 4, 1, and 89. Return me the first 3. And remember, it did not remove them. So if I say print ages, we still have all our ages. Okay? So difference between prefix and drop first, for example, drop first removes, and prefix just returns. Doesn't remove, just returns you those values. Suffix, very similar to prefix, but just instead of the front, goes to the back. So here, if I want to say suffix ages, I'll say ages dot suffix. Let's get the last 2 and say print suffix ages. The last 2 should be 056. Indeed, it is 056. Okay, let's talk about transforming an array. So those transformation functions here are also known as higher order functions. So here I just put higher order functions. We'll come more into higher order functions later. But those are higher order functions. Higher order functions basically returns a function or takes a function. We'll come into functions later. Basically, map, what does map do? So if we have some numbers, we have 1, 2, 3, 4, 5. It's an array of numbers. I want to go ahead and square each element. I want to square each element in numbers. So basically 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So I want to return 1, 4, 9, 16, and 25. I want to return the square value. We could use a for loop to do this, but in Swift we have map. Map is a function that takes a function. So what does that look like? We'll say numbers. We'll come into closures. We'll come into talking about, closures and syntax for closures later into the program. But for now, we'll say numbers, which is an array. We want to transform that numbers. We'll say numbers dot map, which is a function. For now, we will simply use trailing closure syntax. We will come to trailing closure syntax later. So here, what do I want to do? I have my numbers, which is an array. I have map, which is a function. It takes in a closure. Since it takes in a closure, we will talk about closures, but since it takes in a closure, what we'll be doing here is provide closure syntax, trailing closure syntax. And in that trailing closure syntax, since it takes in 1 argument, we'll pass in $0, which is each element. Each element is represented by $0 here. For example, 1, then 2, then 3, then 4, then 5. What do we want to do? We want to square each number. We want to multiply each number by itself. So what we'll do is say 0 or $0 times $0, right? Return me that value. Whatever that equates to, return me that value. So now in our squares array, if I print squares, just like that, what I'll get now is 1, 4, 9, 16, 25, as we said. So map transforms an array. So whatever function or whatever closure you pass in here, it will perform that equation statement and return the value, return the result. Okay, let's talk about flat map. What does flat map do? So if we have an array, let's call it matrix. Matrix is basically an array of arrays here. We have, for example, we have an inner array. We have 1, we have 2, followed by a next array. Here we have we have 3, we have 4. And then we have the next array, we have 5, we have 6, right? So here we have a matrix. If we were to print out this matrix, what do we get? We get one array. This is one array of elements. We have 3 elements. Each element itself is an array. If I was to actually use a for loop and say for, since we have an in array, I'll just call it for array in matrix. So this array here represents each element of my matrix. Here I have 3 elements, and I have an array here as well. Okay, let's actually just make them different lengths. So 5, 6, 7. Okay, cool. So if I go ahead and I print array, just like that, here I get 1, 2, 3, 4, 5, 6, 7. This array represents each element of my matrix. My matrix has 3 elements in there. Each of those elements is an array. So each element of the matrix is an array. So here we have an array of arrays, or you could call it a 2-dimensional array as well, or a matrix. Okay, so here we have an array of arrays, and here you could also loop through this array itself. I could say since our elements in array is numbers, I could just use the constant num. So for num in array, and here I will print num. So let's not print line 202. Let's keep that off. And we'll just print each number. So we'll get 1, 2 printed, 3, 4, etc., etc. Let's just go ahead and run that. So here we have 1, 2 printed, 3, 4 printed, 5, 6, and 7. Okay, great. So here we have an array of arrays. This is how we could print it out. For each inner array, I have a loop on itself, just printing it out, or I could just print out the array itself. So instead of using those 2 for loops here, I want to say, I just want to use one array, right? I just want to use one array. I want to flatten this array. How can I flatten this array to just be 1, 2, 3, 4, 5, 6, 7? Well, that's where flat map comes in. With flat map, I could create a constant here called flattened array, just like that. I could say flattened array, and flattened array, call it matrix dot flat map. So flat map is the higher order function we're after. We're using the same syntax that we used here, trailing closure syntax. And here I will say $0, flat map, not flap map. So flat map. So what does flat map do? If we were to go back and type in flat map. So flat map returns an array containing the concatenated, meaning combine each array, add them together. We have 3 inner arrays, add them together to return 1 array. So flat map, and we just pass in the argument. So $0, again, what does it represent? It represents each inner element. So here I have 1 element, I have 2 elements, and I have 3 elements. So it takes each of those elements and it concatenates them together. It adds them together. And now if I print my flattened array, now I just have 1 flat array, as opposed to having this matrix or array of arrays earlier. So if you have a situation where you want to deal with just 1 array and not array of arrays, flat map would be the way to go. Okay, awesome. On the other hand, what does compact map do? So if we have grades here and we have a series of grades, we have nil, we have 78, we have nil, we have 89, we have 99, we have 59, right? And we have nil. if I print out grades right now, what do we get? So I print out grades, I get nil, I get optional, because if we option click on grades, what is it? It's an array of int optionals, right? Because the compiler infers some of them are nil, some of them have values, some of them are nil, right? So it makes this whole array an array of optional values, okay? The elements are optional. And this is what we have. So wouldn't it be better, like we want to print only valid values, right? I want to print only values 78, 89, 99, 59. I do not want to print anything that has nil values in it. So that's where compact map comes in. With compact map, I could say valid grades. I could say grades, compact map. Okay. Again, we're using trailing closure syntax here. Compact map, and I want to pass in some closure. In that instance, what I want to pass in the value itself. So the value itself is $0. What does compact map do? If we were to go back and see what compact map does, compact map returns an array containing the non-nil results. Does not return nil values. Non-nil results. So it only returns non-nil results of calling a given transformation. Okay, what does that look like? So back with our compact map, I will pass in our shorthand argument syntax. This is $0 here is shorthand argument syntax. So it returns non-nil, so it's not going to return nil, it will return 78. In other words, it unwraps the values. So it returns 89, does not return nil. So what do we have at the end? At the end of all that, we will have valid grades. And valid grades here is 78, 89, 99, 59. Keeps the order. Okay, so back in our earlier explanation of what an array is, it's a collection of elements, a collection of ordered. So what is an array? It's a collection of ordered elements. It maintains the order. So here, if we scroll back down, 78 maintains the order, 89, 99, 59. Okay, valid grades. Reduce, our last higher order function of the day. So here we have reduce, we have a set of, actually we have grades, we have valid grades. So somebody asked us, go ahead and return the sum of the valid grades. Return the sum of the valid grades. We could use a for loop. We could say for num in valid grades, we could come here and we could create a num or a sum variable that keeps count of it. And we could say for each grade, go ahead and add to a recurring sum. So add sum each time you come across num, just add to sum. Add to sum, keep adding to sum. And at the end, we will get the sum. So if I run it, we'll get 325. So if you add 78 plus 89 plus 99 plus 59, you get 325, right? So here we have a few lines of code, 1, 2, 3, 4 lines of code, call it that. We could also do the same thing with the reduce function. So here I could say, let sum of grades, for example, equal to our array valid grades dot reduce. So reduce takes in an initial value. So we have an initial value here of 0. It takes in an initial value and it takes in a closure. Again, we'll talk about closures, but for now, this is just an example. So here we'll say reduce takes in an initial value of 0, which is very similar to our sum here. And it combines the values together. So if we're combining the values together, we need to pass in the method in which we'll combine those values together. Are we going to be multiplying them together? Are we going to be adding them together, right? Subtracting it? Whatever you want to perform, that operation, you pass in the operation here, or the operator, or a closure. In that case, add is a closure. So the add symbol is a function or closure that takes two values. So this add here takes two values. In our case, the first value is 0, and the second value is our first num, which is 78. And the next value, the initial will be 78, and the next will be 89, and so on and so forth until we're done adding everything together. So this is what the syntax looks like. Takes in an initial value of 0, very similar to sum, and takes in a closure. In that case, we just pass in the add symbol. And pretty much that's it. So at this point, we'll just say sum of grades, and we run it. And here we get the same value, 325. Okay, let us continue on. Next, we have sort in place. So what does that do? If we want to sort our grades, for example, let's say valid grades dot sort, right? Sorts the collection in place. What does that mean? Does not return a new array, modifies the current array. Okay, so I have valid grades. If I just go ahead and print valid grades, it will be sorted. Sort cannot mutate. Okay, so our grades here needs to be, valid grades here needs to be a var, because we are now sorting it in place. It needs to be able to be mutated, so it needs to be a var, a variable. So if we run it again, now we have 59 in ascending order. So it sorts it in ascending order, meaning from small to big. So 59, 78, 89, 99. So this was not sorted, right? But now we have it sorted in place. We just sort like that, sort the function, right? So we have sort that takes in a closure. What does that look like? So here, let's do sorted grades. And this time we'll sort it in descending order using a closure like we saw earlier with reduce and compact. So here we'll say valid grades sorted, also a higher order function. So we take a closure. So this closure, all the closures we've seen so far, basically it takes like one argument. For compact takes one argument, flat map takes one argument, map takes one argument, reduce here takes two arguments because we have the initial and the closure, but sorted here takes two arguments. So to use shorthand syntax, if you take in one argument, the first argument is $0. If it takes in two arguments, you need to pass in $1. If it takes in three arguments, you pass in $2, and so on and so forth. So what we want to do here, we want to sort in descending order. So let's see what that looks like. So I'll say descending order like that, where the first value is larger than the second value. So what does that look like? With our grades, for example, if I print sorted grades and run that, it's descending order. So it goes from big to small. So descending is big to small. So descending looks like this, the more than sign. So this is descending, big to small. And ascending is small to big, right? Or large, large to small, small to large. Right, so what does that look like? I would go from 10, 9, 8, and so forth. This is descending. Ascending, on the other hand, is 1, 2, 3, 4, 5, 6. So here we could pass in a closure, determine how we want to sort it. If we want to sort it descending, we pass in the more than sign, we get 99, 89, 78. If we want to say ascending, we pass in the less than sign, and we run the code again. And this time we get 59, 78 like before. So sort here is ascending by default. And if you want more customization with how you sort your array, use the closure sorted, okay? And here we just pass it more than sign, and this is what we have here. Great. Other things we have reverse. If I want to reverse some array, so just say some numbers, and our sum numbers is 1, 2, 3, 4, 5. And I want to reverse it. I could say sum number dot reverse like that, and print some numbers, some numbers like that, numbers, and run it. Well, here again, we cannot mutate because this needs to be a var. So run. So now I get 5, 4, 3, 2, 1. So dot reverse reverses elements. Okay. So 1, 2, 3, 4, 5 gets reversed, 5, 4, 3, 2, 1. And this is sorting in place. So sort or reverse in place. Okay. On the other hand, this reversed returns a new collection. Okay. It doesn't reverse the actual same element. So if we say, let's just say new reverse here, and say some numbers dot reversed, and if we were to print, it's gonna be 5, 4, 3, 2. That's what we're looking for. So if I print some numbers, that doesn't change. It's still going to be 5, 4, 3, 2, 1. Right? It's still 5, 4, 3, 2, 1. It didn't change, but this new reverse is changed. So if I say print new reverse, and you need to type annotate this to say integer. And now I have 1, 2, 3, 4, 5. Okay. Shuffle, if I want to shuffle numbers, so let's say shuffle my array. I want to shuffle it. So say some numbers dot shuffle. Well, shuffled would return a new shuffle. Let's keep this one for here. And this one, if I say print some numbers dot shuffle, this one sorts in place, or rather it does it in place. So shuffle in place. Anytime I say in place, it doesn't return a new collection. So if I run that, we need to do two things. It doesn't return anything, so I cannot print, first of all. And second of all, I could just print now. So print my sum numbers, and this will be shuffled. There we go. This is pretty shuffled, 3 to 5 for 1, okay? Shuffled, on the other hand, returns a new array. So if I print shuffle elements, and I run this, shuffle elements, 4, 3, 5 to 1. Okay, so one of them does it in place, and the other one returns a new collection. Swap at, let's see, swap at, let us do arranged numbers like that. And we have 1, 2, 3, 4, 5. If we want to swap two values, we could use swap add for that. Arrange numbers. Now again, since it's modifying the same array, it needs to be a var. And here I want to swap two integers together. So say I want to swap 0 and 1. I want to swap index 0 and index 1. I want to swap basically 2 and 1 position. What does that look like? So here I could say print arrange numbers. Flattened array. What am I using? Oh, sorry. Arrange numbers here. And here you see we swapped the first two values. So I swapped the values of index 1 and 0. I just swapped them together, right? In place. Okay, so you could just swap two given integers in an array using swap add. Next, we have partition. Basically, what does partition do? The best way to see this is in an example. Let us take some numbers, and let's just do some random numbers. So this is pretty random. And the question was, go ahead and sort them such that everything that's some numbers 2. We want to somewhat partition separate. We want to separate the array such that the smaller numbers or numbers less than 10 is to the left, numbers greater than 10 is to the right. How can we do that with partition? Well, we'll say some numbers dot partition. Again, this is a closure. So here we'll say $0. It takes in one argument. I want to sort it such that I want to partition numbers that's greater than, let's say 9. So anything that's greater than 9, put it to the right. Anything that's less than, keep them to the left. And this returns a value. The value is known as a pivot. So it returns a pivot, right? Wherever it separated, the partition happened, it returns this pivot to us, which is an index. So here I could just say pivot index, actually. So it partitions in place. So if we print what the new sum numbers 2 is, right? So if we take a look at this, did I run it? Some numbers 2 here, sorry, and run this again. So some numbers 2, everything got partitioned here. So everything to the right of 10 basically is larger than 9. And everything to the right is smaller than 10, okay? Okay, so there we are. We say partition, it returns a pivot index. It also partitions in place. So here, this is what the new array looks like. And here we have everything greater than 9 is to the right of the pivot, and everything less than 9 is to the left. So let's print what the pivot is actually. So print pivot index. So the pivot index is 5. Remember, index starts from 0. So if it's 0, 1, 2, 3, 4, 5. So the pivot is right here. So everything from 10 it took and it put it to the right of the array. So the pivot is right at 5. So we could go further. We could say let lesser or less than 10 values. Or values less than 10, rather. Values less than 10. Values less than 10. And here we could take in our sum numbers 2. We could use a range. and go up to our pivot. We don't want to include the pivot index. So we'll take a half range and we'll say pivot index. We'll say pivot index just like that. So values less than 10. And here we'll say values greater than 9. So here values less than 9 actually, and values greater than 9. And here we'll say some numbers. And this time we'll take the pivot index. We'll take the pivot index and include everything from the pivot index, which is 5, all the way to the end of the array. And let's print those two out. So let's print values less than 9. And let us also print values greater than 9. This should really be values less than and including 9. Let's just put a 9 in here because we also want to include 9. Let me run this again here. Okay, so values less than, let's just put 10 here, sorry. Values less than 10, values less than 10, this is good. Values less than 10. So values less than 10 includes all those numbers here, and values greater than 9 includes all those values here. So if you want to somehow partition some array, partition here is very useful for that. Okay, very good. So to wrap up, let's talk about split and joined. So the easiest way to show split is create a string. We're talking about arrays, but a string is some sort of a collection of values. So here I will say Alex is an iOS developer. So here we have a string, and I want to create like a string array, for example. So I'll say string.split. I want to split. So what does split do? It splits at some character. So here I have to pass in a character. In my case, I'll pass in the space character. So this is a space character, space character. So what I want to do is split this string everywhere I see a space and create a collection. So what does that look like? If I print string array, I get Alex as one element, is an iOS developer. So here I have 1, 2, 3, 4, 5 elements. Okay, 5 elements using the split function with some character. You could pass in any character you want. For example, I could pass in E, which is going to be a little weird here with how I split my stuff here. But it would split it everywhere there's an E, it would split. It would cut off the array, right? Let's actually go back to our space. Okay. So here we have Alex is an iOS developer. If I option click on string array, I see a string of subsequence. And next, joined. Let's take a look at what joined is. So if I have an array of, let's just say string, we'll create a next string array. I have Bob. I have John. I have Sally. So here I have a string array, and I want to create a string from it. So new string. I want to create a new string. I basically want to create a string from this array. How do I do that? I would simply say string array dot joined, which returns a string. Okay, so if I go ahead and print new string and run that, I get Bob, John, Sally. It would be nice to maybe pass in some sort of character to separate them. So we have that. I could pass in a separator, right? I could pass in a comma, just like that, and run my code again. And this time I get Bob, John, Bob, comma, space, John, comma, space, Sally. Okay, so this is a cool way to take some array and join the elements with some separator. Okay, we went through a lot today. As always, thank you for coming, and do feel free to like this video and subscribe. Thank you very much.